Welcome to GeekNerd YouTube channel. Uh, Today I'm going to solve the fifth question, that is maximum count of positive integer and negative integer. So before I have solved the four questions and I have uploaded the solution. You can hover over it and click the link and you will redirect to that video. Um, Sorry for coming so late after the last video because I was in some uh, work, so that's why I couldn't make video. But from now onwards, I will try to make video every day. So, so today we are going to solve the maximum count of both positive integer and negative integer. So let's move to this question. If you want to go to this question, then you have to just hover over it and then click that link. So this is the question. So let's read the question first. This is the question number 2529. Maximum count of positive integer and negative integer. Given an array num sorted in non-decreasing order. That means there is a number that is in the non-decreasing order. Return the maximum between the number of positive integer and number of negative integer. If, in other words, if the number of positive integer in nums is post and the number of negative integer is net, then return the maximum of post and net. Note that 0 is neither positive nor negative. Here in this question, it is asked to count the number of negative and positive integer, and the array is in the non-decreasing order, and we have to return the number which that is maximum of the number of negative integer and the number of positive integer. And the zero is not considered as a positive nor negative. These are the conditions. So the brute force, first we start from the brute force approach. We'll um, iterate over the array, and if we find the negative integers, then we will have a two variable that will count the number of positive integer, negative integer as pos and net, and will increase the pos if we find the positive integer, and it will increase the net if we find the negative integer, and at the end we will return the maximum of the both. So here in this example, let's look over the examples to understand the question more. So here in the example 1, we have -2, -1, -1, 1, 2, 3. So there are three negative integers and the three positive integers. So the maximum of both of them will be 3. So here we will return 3. And here there is -3, -2, -1. There are three negative integers. 0, 0 is not considered as positive nor negative. And there is 1, comma 2, which is positive. So there are two positive integers. So as there is two positive and three negative, so 3 is greater than 2, we return 3. Yeah. Here in the third example, we have a 5, 20, 66, and 1314 is there. So here there are four positive integers, but there is no negative integer, so we return the 4, as 4 is greater than 0, right? So let's do the brute force approach, where we will iterate over the array, and we'll have the two variables called pos and net, and which are counting the positive and the negative in number of integers, and will at the end we are returning the maximum number. Okay, so int pos is equal to 0. Okay, if you can't see it, then I will make it bigger so that you can see it properly. So int pos and int pos and the net. Actually, I should do it before. I should increase the size font bigger. If you are unable to see the question before, then go over this question and read it by yourself. And by my explanation, I guess that you will be able to understand the question. If you're not, then okay, I will explain the example one again. Okay, explain. I will explain the example two. Here, minus 3, minus 2, minus 1 is there. So there are three negative integers. Zero zero is not considered as positive, not either neither negative. Okay, and 1 2 is positive. So there are three negative integers and there is two positive integers. So 3 is greater than 2. So whichever it is greater, we will return that pass. Okay. So first we will consider, we will have a pause and a net variable. Then we'll iterate over the num. So int num. And if we find num is greater than 0, then we will increase the pause by 1 and will neck will increment the neck. Okay. Then we have to return math of max of pause and neck, whichever it is good. So let's run it and see is it passing or not. Okay. One test case doesn't pass. Okay. Uh, by the way, there might be a chance that it is the num becomes 0. So we have to show you that num is less than 0. So for this, okay, let's rerun again, and I think it will pass. Okay, passed. Why it fails before? Because sometimes that num might be 0 also, right? So in case we encounter 0, we will not increase an egg. Okay, so that's why. We will submit it. Let's see, is it passing or not? Is it is passing? But what is the time complexity of it? The time complexity of it is big O of n, I think, right? Because we are iterating. In the worst case, we find we'll have to iterate over the whole num. Okay, in every case, we have to iterate over the every integer in the array. So here the time complexity will be big O of n because we have to search for every element. But there can be a better solution than this. What can be the better solution? What we can do, we can apply a binary search in it. We'll search 0 by binary search. We'll go like went to the middle and search not particularly 0. If you find 0, then it's okay. Like that is the point where we have to go right and left and find the negative and non-negative integer. But what we can do is first we find the particular point where the right element is positive, but the left element is negative, or the current element is negative or positive, but the right and left should be different or zero. Okay, so with that we have to do. So here we will use binary search. How will we use it? Let's have a space here and do some brainstorming. So let's take this example minus 3, comma minus 2, comma minus 1, comma 0, comma 0, comma 1, comma 2. Okay. How many numbers are there? 1, 2, 3, 4, 5, 6, 7. 7 are there. So we'll index it to 0, comma 6. So first I will point to 0 and say will point to 6. Okay. And 0 plus 6 by 2 is 3. Then the mid will be I will point to 3. Okay. So 3 means 0, 1, 2, 3. Here we find 0. So if the if mid is equal to 0, then what we have to do? There might be multiple 0, right? So what we can do, um, we just find iterate over int uh, sorry, int let's make it k. K is equal to mid, and we'll iterate until the number until we find this k is equal to a negative, like the number that is there in the k index is negative. So first the thing is k should be greater than equal to 0, greater than equal to 0. Okay. And uh, let's say nums of k should be until we find like should be greater than equal to 0. So until we find negative integers will not come out. Okay. If it is positive, then we'll continue it. Okay. So then we'll decrease the k. Or either we can mark it as a point. Okay. Better to have a point. Okay. Right. Hmm. So whatever the solution is, suppose here we'll iterate and then we reach to 2. Then that means the 2 index is the one that have the negative integer. Before that, everything is negative as the array is in the non-decreasing order. So if we encounter a negative integer, that means the left of it will be negative. So here, if the index is 2 and we encounter a negative integer after 0, then that means there is the number of negative integer will be what? The index plus 1. So after that I will increase it by 1. Okay. So for this, assume that a is the number of negative integer in case we encounter a mid is equal to 0. Okay. Then let's make it b also. B is equal to mid, and for this, we'll encounter number of positive integers. So we'll move to the right part. Okay. So first, the b should be uh, less than equal to, and not less than equal to, less than a dot length, nums dot length, because we can't go beyond the array. Okay. If the size of the array is 5, and if you want to find the element at the 90th index, then it will throw an exception and your test case will fail. So you have to have a check that for if you're going left, then your index will be greater than equal to 0. If you are going right, then the index should be less than the size of the array. Okay. Then you have to implement nums b is equal to less than equal to 0. Okay. Until unless we find a positive element, we will do a plus plus. After that, what we are going to do is the index. If we find what will the index we will find after this. Here it is first we have the mid here. If we plus plus it, then it will be 0. As we find 0 again, then if we increase it, okay. This is the index 1, 2, 3, 4, 5, 6. We will encounter the sixth index. Okay. The sixth index and the number of element 1, 2, 3, 4, 5, 6, 7, 8. No, sorry, 1, 2, 3, 4, 5, 6, 7. So 7 elements are there. And sorry, not 0, 1, 2, 3, 4, 5. So we'll encounter the fifth index. Okay. And the number of elements are 7. So we have in this array we have two positive integers. So to make it such like that, then we have to decrease it by the number of the length of the array. Okay. So here we will find the number of positive integers in that array. and just we have to return math dot max of a comma b. We are going to do that if we encounter any zero in between. Okay. What if we didn't encounter any zero? So let's remove the zero. Now, what is the size of that array? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5. The five, the length of the array is 5. So initially I will be 0 and j will be 4 because the last index is 4. So for now it is the mid will be 2. Okay. So the mid will be 2, then the the index that is pointing to 2 is minus 1, which is less than 0. Okay, here I should do like this. Okay, sorry. Else if else if nums mid is less than 0, then what will we do? We are if we find the if we find any element that is less than 0, then what will we do? We will make sure that um, the I should be greater than the I should be we increase the I by 1, right? So we'll make I is equal to mid plus 1. In the other case, we are going to decrease the j mid minus 1 because we have to a find find what do we say? Find a index where um, the left the sorry, we have to find a index where there is a transition from the negative to the positive, so that we can find a particular index where we like by which we can uh, by which we can count the number of negative and positive integers. Okay, so this is the case, but if we do that now, then if you don't find any zero, then this loop will continue, right? So we have to have some edge case here. So what should be the edge case? Suppose we find that in the like the mid is 2, so it will find negative. So we make it I is equal to 3. Then we get that we get what we get. We get that yeah, I is equal to the number that is pointing the index I is 1 and the index is 2. So we don't get anything from here, right? So what we can do? Let's think. Let's think. Mm, okay. We can have a check that when we find a mid, when we are not doing this, like initially when we find minus 1 in the mid, so we could check that the left of the right and the left of the element is it a positive or negative or not? So so suppose the nums of mid is negative. Okay, we can here only suppose here the nums is negative. So is the nums of mid plus 1 is positive. Okay. Hmm? If it is positive, then uh, then what we would do if it is the right and is positive, then we are returning math dot max of uh, what the current index plus 1, like mid plus 1, comma, because the current index is negative, so the left side of it will be negative. So the number of negative element will be the correct index plus 1. As we have seen here, we have to increase the a y because we the current if we have to calculate the le- every element on the left side of that index, including the current one, then we have to increase it by 1. Okay, to count it. And if we find that the right index is greater than 0, then what we will do um, is okay, that we we have to um, num dot length minus mid plus 1, I think, because okay, let's suppose this is the index where we find it. So we want 2, because there are two positive integers, 1, 2, 3, 4, 5. 5 elements are there. We have 2, so 5 minus 2 is 3, and not plus 1, it's minus 1. Okay, fine. I will explain it later. Okay, so let's add the logic again for this also. Mid minus 1 is less than 0, then we'll return the math dot max of uh, if we find the positive number, then okay, suppose we are there in the 1. It is a positive number and left of it is a negative. So we find the left is negative. So here we are in the 3 index. So there are three number of three. There are three negative integers. So that is the index will be the negative number. But for this nums dot len minus mid will be best. Okay, this is what the logic looks like. Okay, let's run it. Run it. Mm, So the first index will be 0. Second index will be nums dot len minus 1. Okay, and we will have a loop while I is less than j. Mm, Okay, another thing. I have missed it. Suppose what if 1 2 will be not there, and uh, by anyhow I'm reaching to the minus 1, which is the AND index, and I'm doing mid plus 1, then it will be a disaster, right? It will be a disaster, right? Because uh, because there is um, the number that are there are every number is negative, right? So we can't do this like this. Okay, so we have to check, as we are checking the mid plus 1. So we have to check the mid plus 1 is should be less than nums dot len. Okay, and then for here we have to check mid minus 1 should be greater than equal to 0. Okay, let's copy it and put it inside. We continue this loop until uh, until um, until the is lesser than the j, because every time we don't find a satisfied solution, then we are increasing I and decreasing j. Okay. Hmm. Let's hope. And for that case where the everything is negative and everything is positive, it will go out of the while loop and will return the num total. Okay. I hope this pass. If it doesn't, then we'll check what is wrong. Okay. I missed semicolon. Okay, mid is not initialized, right? Okay, okay. We have to initialize mid. Int mid is equal to, for now I'm doing let's say by 2. But there is another way. Uh, for the last number, okay, it's passed. So like for the large size of array, we shouldn't do like that. We should like do like j minus I by 2 plus I. Okay, but it failed. Why it failed? 1, 2, 3, 4. Okay, it is the size of it is 15. So I think it gets out of the array. Um, I think in this array by anyhow it reaches to the 0, but it is because the I have put like that the I should be less than j. So I should do like this. And okay, let's fix this just something on it. Okay, it passed. If 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 I and j is pointing to 0, then it will fail now. So here the test case passed. The time complexity for this code is the O of log n, which is more optimized than the previous one. Okay. Hmm. So more optimized than the previous one. And I think that everything is good. You understood this question, but I'm going to explain it again to you because you might not understand what is happening here. Huh? Okay. So here, as we took an example that if if there is one and two, and suppose think like that, if your mid and count, if your mid is this, then from this, what can you get? Like what kind of solution can you think of? Like if your midpoint to this one, because we know that from this point, from the left, everything is negative, from right, everything is positive, right? So if we think about it, then we can from this point we can generate answer of it, right? So including this, everything on the left is negative. So if we find the index, what is the index here? Index is 2. So there are the index is like as the index starts from 0, if the as the index here is 2, then the number of elements that are there in the left side is 2, right? And we are including the current one also. So mid the index plus 1. So that is the number of negative element. Okay, if we encounter this kind of this kind of case. Huh? But for the positive, if our index is pointing, if our mid pointing to this point, then the entire element that are left, that is inside the that is there in the left side of it, will be the number of negative element, excluding the current one, right? So that's why I have added here mid, right? Hmm? And if we are there in this, then what will be the number of negative integer there? Means the entire element minus this number of element. So there is mid plus one element, negative element, the num length minus mid plus one, that is minus one, right? Or either we can write like this, m plus one. right? But we have open the bucket and it look like this, right? Same goes for this also. So if we encounter this kind of solution, then there is no zero in the array. Okay. I hope you get it. If you have any doubt in these questions, then you can comment down below. I will see the comment and I will reply to that comment. So I hope you have understood this second solution also. First solution is very easy. Try to it by yourself. You will understand it gradually. Okay. Thank you. Meet you in the next video. Till then, like the video, subscribe to my channel. It will motivate me to make more videos in it. So thank you. Bye.